Fantastic. All right, so my differential equations training from years ago would tell me that I think we're all here. We're going to have about 2 standard deviations out that are going to be walking in. That's all right. This next session is going to be a session on mitigation practices. What's available to you is important to understand that I think it's been brought up a couple times throughout the day that just because a developer says, here's how it is, doesn't mean it's how it has to be, that there are alternatives. And those alternatives are all pieces of the puzzle of how to create harmony between this technology and the society that we live in and who we are. So it's a pretty fascinating palette of options out there in terms of siting, in terms of grouping, in terms of number of machines, in terms of type of machines, in terms of how the machines operate, in terms of who operates them, in terms of how you communicate with your community, et cetera, et cetera. There's an entire spectrum of mitigation out there. So we've got a pretty full deck, a powerful panel for you, which I think will provide you with a bit of horsepower when we get to the question and answer session. So I want to kind of rush us to that, and I apologize to our 2 speakers, 2.5 speakers, I'm a half speaker, as we do that, because it may seem a little hurried to you, and if it is, it's just because we want to get to the point where it's dynamic and interactive. A little bit about my background, just so you know what that is. I'm an NREL guy. I was at NREL for about a decade, was getting to the point where I really needed to get some field experience. Took 5 years, built about 100 projects, mostly small projects from 50 kW up to a few megs, and then have recently stepped back into NREL with that experience. So to that end, I see mitigation as kind of this picture here. Not very good. I forget how you launch. Oh, look at that. The notion of mitigation is that you have a situation. What do you do about it? The situation here is that we've got a storefront, not a wind turbine, but when people come into the store, how do you not have them slip? That's called a rubber mat. And it's something you have to think about. Every time we turn around, there's another step that somebody else has taken to keep us from falling off a road, tripping on a curb, doing something else. And mitigating wind energy projects is no different. It's putting up guardrails so that we don't do things that we regret later on. It's working with each other so that we can be where we need to be without alienating anyone. So to that end, I want to introduce our first speaker, if I can figure out how to run Microsoft again, because I'm a Mac guy, I'm sorry to say. Actually, I'm proud to say. Our first speaker is Benjamin Bell. Ben Bell has been around the industry for a very long time. When you look at his resume and you kind of say, oh, wow, Flowwind, that was back in the days with the egg beaters in California. He was with U.S. Wind Power and Kenetech. Kenetech had 4,000 or 5,000 machines up. He's gone through Zond, through GE, and now he's with GLGH, or Garrad Hassan, one of the premier consulting and product companies in the world with regards to wind energy. So we are very, very fortunate to have Ben. And Ben, without further delay, I invite you to join us.
Well, thank you, Charles. Appreciate the opportunity to be here this afternoon. I'm going to move through this fairly quickly, but essentially what I'd like to talk about here are wind turbine design and operation aspects and how to mitigate impacts using that. Just a little bit of background on our company. We have roughly 700 engineers around the world in 38 offices in 23 countries. Here on the East Coast, we're located in Peterborough, New Hampshire, just outside of Boston. So essentially we're looking at I'd just like to review a U.S. historical perspective and the design evolution of the machines, and then some of the things that have been done over the years to minimize the impacts associated with the turbines, and then key factors to consider during the development and also the operational phase of the projects. So this is a slide that I credit to Walt Musial at NREL, a good friend of mine, which essentially highlights the first decade of wind in the United States, which was coined by Sandy Butterfield out at NREL, being a period of irrational exuberance, we really had quite a potpourri, so to speak, of various turbines out there in the market where we had foreign machines coming in, a lot of those still available on the market, Vestas, Bonus now becoming Siemens and other turbines. Then we also had U.S. companies involved in this, Kenetech, Flowwind, ESI. A lot of these technologies have developed into what GE is selling today. One of the things you can see in this slide is at the end of the renewable energy incentives in California, roughly in 1985, you can see that the rest of the world, and particularly Europe, starts to move away from the United States as far as installed capacity is concerned. So it's been a bit of a boom-bust industry over the last 30 years, but we have learned quite a bit in that time. If you look at some of the early machines that were deployed in the early 80s, you could see there were upwind machines, downwind, 3-bladed, 2-bladed, various mix of machines, and the U.S. installed capacity back in 99, only about 2.5 gigawatts. It's changed quite a bit since then and started primarily on the West Coast, has been moving east ever since. Some of the things that have been done to design minimizing the impacts, we were evaluating, should we be using tube towers or lattice towers? I think our early experience in Altamont Pass and other places showed that the lattice towers weren't such a good idea when it came to, with respect to avian issues, birds roosting on the towers, etc. Combine that with downwind machines where birds typically like to take off and land into the wind to be able to get on the towers to roost. They would have to go through the rotors. Another big disadvantage with the downwind machine is the fact that, as someone has pointed out earlier today, I believe Ken did, that increased noise associated with the downwind machines because they have to travel through the wake that's coming off the towers. So you don't see too many downwind machines now, but then again, there haven't been too many purpose-built offshore wind turbines yet. And so where we have machines out of hearing distance from populations, I think we might see downwind machines resurface again, as well as two-bladed machines. From a visual aesthetic standpoint, people are less comfortable looking at a two-bladed wind turbine as opposed to 3. So there have been quite a bit of evolution over the time. That's also with respect to horizontal or vertical axis rotors. In the 80s, we saw quite a few of the vertical axis machines, but efficiencies associated with those have really eclipsed them, and now turbines, the horizontal 3-bladed machines are really the configuration of choice. Same thing with the number of blades. Smaller, large rotors. Hard to believe that what you're looking at here is about 2 megawatts in each of these pictures, ignoring the large Vestas machine in the background there. There's 50 of the Vestas 55 kilowatt machines that were deployed in Tehachapi back in the 80s as compared to one V90. Quite a big difference in the view shed associated with the size of these turbines. So over the years, there has been a real design evolution, moving from the very small machines you can see on the far left there. That's a 56100 U.S. wind power machine that was installed on Mount Equinox back in the late 80s, 18-meter diameter, 100 kilowatts. And over the years have been evolving into these much larger units, with the largest machines in the world now being rated at about 7.5 megawatts, or about 126 meters in diameter. Quite a big economy of scale, obviously introducing new issues associated with permitting, acoustics, etc. But that's generally where the trend has been going in the machines. The blades are big. This is the LM 61.5 meter blade. And as you can see, some of the issues associated with dealing with these rotors is really just moving them around. And that one is not the biggest. Vestas has now come out with a new 150-meter rotor. So if we see where we are today, or at least as the end of 2010, roughly right now we're at about 42 gigawatts in the United States. So quite a big change over the last 30 years. As you can see, things moving to the east, and now projects coming up in Maine, New Hampshire, etc. And so it's really come a long way over the years. Once again, it's getting back to the scale size again, the small 22 megawatt machines on the right, and now the machine size of choice in the 2 to 3 megawatt range for land-based applications. A lot of you probably have seen this picture of the Boeing 747, but essentially taking that, a rotor that size and spinning it at 15 to 18 RPM. It's quite large structures that introduce a number of new issues associated with integrating them into the environment. Plus, these machines are very high duty cycle turbines, roughly 100 million load cycles these machines experience. If you compare that to an automobile in its entire life, if you ran it constantly, would only run about 9 months. So as far as a wind turbine is concerned, about 8 or 9 months of operation would be analogous to the life of an automobile. So really, they are the largest rotating machines and also have the highest duty cycles out there. How does this relate to key factors to consider during development and operation? One of the things that generally has to take place, as you're all aware, in going through a siting of a project would be the environmental review and permitting, looking at endangered species in the areas, avian and bat studies, visual aesthetic studies, shadow flicker studies, historical and archaeological review, wetlands review, and noise studies. Things that have been done over the years to mitigate the impacts associated with the turbines. First and foremost, proper siting of the machines to make sure that they're not located in sensitive areas. Moving upwind versus downwind has reduced the noise. Moving to 3 blades as opposed to 2 has improved the visual aesthetics for most people. Going to tubular versus lattice towers has taken away a place for wildlife to roost. Getting away from reflective coatings so that you're not getting flicker off of rotors, and also the advent of new audio-visual warning systems like the OCAS system that essentially would turn on and off the FAA lighting dependent on whether or not there is an aircraft in the area. Plus, there's also not only design issues, but operational issues that can be considered, like I mentioned on the lighting systems on the OCAS. Plus, there's also when you operate the machines, dusk to dawn idling. And I have a particular case study here that I would just review, and this would be with respect to bat impacts and mitigating the impacts on this wildlife. According to current studies, there are roughly 3 bat species that account for the majority of mortalities at wind farms. The hoary bat, the eastern red bat, and the silver-haired bat. All 3 of these bat species are migratory. None of them are currently classified as threatened and endangered. And that we're seeing the fatalities peak during late summer, early fall migrations, and similar but smaller peaks during the spring migration periods. Exact reasons behind why and when bats collide with turbines is currently unknown. However, it has raised quite a bit of concern, and a lot of studies have been done to try to mitigate these issues. There's the Endangered Species Act, state wildlife laws that need to be upheld, and also in many states, comprehensive permit applications. Generally, a bad PR issue associated with taking this type of wildlife, and these studies can last several nights to several months and range in cost anywhere from $50,000 to $100,000 each, which really does make it difficult for community wind type applications. The current technology also can't always decipher what type of bats are involved here, but likely, that if bats do occur on a project site, the state wildlife agencies will recommend 2 years of post-construction monitoring at a cost of about $50,000 per year. Some of the reasons for bat mortality is really unknown, why bats are killed by turbines and why some species appear to be more effective than others. But there is growing information about the mortality events and reason for the mortality. Bats can be killed by direct collision or from barotraumas, essentially flying into the low pressure zone behind a blade and having their internal organs, due to the low pressure, causing them to burst. Mortalities appear to be concentrated in low wind speed nights during the migratory periods and possibly shortly after the passage of storms. So some of the suggestions include proximity, attraction, migratory behavior. And the greatest impacts that are currently being seen in the United States generally are being seen on forested ridge tops in the east, whereas lowest mortalities are seen in the west. This is an infrared image of a bat actually colliding with a wind turbine rotor. The purpose of this project, that we did a study where it was to analyze and estimate and quantify the impacts of bat curtailment strategies on the energy output of wind farms. And the comparison to actual mortality reduction estimates were limited to the field studies available. But we did take measurement data from 60 sites over 170 years of time series power data. and the data was matched with local daily sunset, sunrise times. And 3 field cases were reproduced. One was full curtailment at night, cut in at 5 meters per second, roughly 11 miles per hour, and then April to November night hours, raising the cut in up to about 14.5 miles per hour. This was for a site in Pennsylvania, the Castleman Wind Farm. These are the power curves from the 3 machine types, 3 different cut-in scenarios where full curtailment in black, 5 meter per second wind speed cut in, it's in the blue, and in the green, the 6.5 meter per second. Looking at the bat fatality studies for the higher cut-in wind speeds, in 2008 and 2009 showed that by delaying cut-in wind speed, there was actually quite a reduction in the bat mortality rates for this project. Looking at the total annual energy loss by cutting in at 5 meters per second as opposed to 6.5 meters per second, most significant in the Northeast, where it would have total energy loss, would be on the range of about 3%, but still fairly insignificant when you consider the fact that given a 1 to 3% annual energy loss, the bat mortality reduction actually went down between 44 and 93%. And so from a curtailment effectiveness standpoint, which is essentially defined as the bat mortality reduction divided by the percent energy loss, significant gains could be made just by a fairly simple change in the control strategy of the turbine with fairly minimal impact on energy loss. Our perspective on bat curtailment is that it's one method to reduce bird and bath mortality rates, but shouldn't necessarily be the first approach, and that we support proper siting of projects, adequate surveys, and the use of mitigation techniques as a way to prevent site mortality, and that post-construction baseline studies may be a first step of understanding whether or not curtailment is a viable approach. Regional differences, I'll just go over these quickly. These slides will be available on the website after the conference. These are various projects and the number of fatalities per megawatt per year. The Castleman project noted. There's some New York projects here. The largest coming in through the Northeast, Mid-Atlantic, others. Summary, over the past 30 years, wind turbine technologies have developed and environmental impacts have been mitigated through smart design, proper siting, and responsible operation. Review of endangered species, avian and bat studies, visual aesthetic studies, historical, archaeological, etc. are very common now in wind project environmental review and permitting. We showed a case study here that at wind farms with bat curtailment studies, low wind speed curtailment is an effective means of reducing bat fatalities. Additional research is obviously needed. I would like to make a disclaimer here that bat mortality reductions are based on a limited number of studies at sites with observed high bat mortality. Caution should be taken in extrapolating mortality reductions to other sites, but projects that are cited to avoid bat interference or that employ other mitigation techniques may not see comparable mortality reductions. I've just listed some references here on this topic for your reading, and thank you very much for your interest.
Thank you, Ben. So that's a very fast overview of mitigation strategies that are out there. Clearly, machines have gotten smarter and smarter over the years, from when they were just an on and off switch to machines that can now be curtailed depending on environmental conditions, wind speed, wind direction, time of day, precipitation, etc. So that's the technical approach. And what we also want to talk about is Kevin Schulte. Kevin Schulte is the CEO with Sustainable Energy Developments. He's associated with UMass because his professor down at JMU went to UMass with Jim Manuel, so it's kind of a neat process, I think. And Kevin's company, SED, has an amazing rate in terms of community acceptance of his projects. And I think that's a lot due to the fact that Kevin's group actively manages that part of the conversation. So while I try to figure out how to bring this up, Kevin, come on up. There we go.
Hello, everybody. So my job today is to talk about non-technical mitigation strategies. And really, from my perspective, the one tried and true non-technical mitigation strategy is really good development practices, to be an honest developer, and to really tell and integrate yourself with the stakeholders to explain exactly what the project is going to look like. This can only be done through experience. Our company, we were founded in 2002. We're 100% privately held, and we have about 8 total megawatts of installations, about 25 million kilowatt hours of production, all in the Northeast. Our projects, our first major installation was Chimney Peak in 2007. The purple were under development at that time, and as you can see, we have had some impact over the last 5 years. And we currently operate 44 projects around the northeastern United States. We have an average project life of about 3 years, which means we have 143 operating years for all of our projects. Some interesting things as I talk about why or when we've had to mitigate projects. In the immediate municipality, village, or borough of where our projects are, there's about 800,000 people. But in the counties represented by our projects, 9 million people, or about 3% of the United States' entire population. Between 4 of our projects, Holy Name, Medford, Williamstone, and St. Mary's Abbey, are viewed by 500,000 people a day, according to Mass Department of Transportation records. And then 2 of our projects, our 2 ski resort projects, Chimney Peak and Berkshire East, see more than 400,000 visitors each year, and have increased year on year about 10% since the installation of the machine. So this slide is not to brag or to boast, but simply to say that our projects are integrated amongst people, and we've answered the hard questions and seen very little to no negative public response. In fact, with 44 operating projects, we've seen exactly 5 complaints about our 44 projects. The Hyannis Country Garden project in Hyannis, down on the Cape, we've had 2 problems with the screeching noise, which was because the brake pads were improperly installed upon installation of the machine on the yaw ring. And we've had 1 with shadow flicker, and we engaged a curtailment opportunity for certain hours of the year in the first year of operation. We took the mitigation strategy out in the second year after a conversation with the complainant, and they never complained again. That machine's been operating for over 3 years. Woods Hole Research Center is, we basically are mitigating the machine by shutting it down for about a 20-degree sector of direction when the wind blows. So if the wind is blowing from a certain direction sector, the machine shuts itself down so it doesn't cast a noise shadow onto any of the nearby neighbors. The nice thing about it is the sectors are from the north, which is a very rare, powerful wind in Massachusetts coming from the north. So it's had minimal to no impact on the actual production. The Holy Name turbine, we were interrupting someone's TV signal. There's some videos out there of when you can actually see the blades going through someone's TV. Well, in 2008, when we installed the machine, it was only 3 months until digital cable became the only cable available. So basically, we paid the guy's cable bill for the 3 months until he had to get digital cable anyway, and we never heard from him again. The University of Delaware, it was only $20 a month, so it wasn't really a big deal. The University of Delaware, we are in an ongoing conversation wrapped around noise. The complainant is more than half a mile away from the turbine, and there are about 30 houses between the complainant and the actual turbine. This is a 2-megawatt Gamesa machine. And we actually have done post-installation noise studies and basically proven that the guy's kind of a curmudgeon, and really his complaints were kind of invalid, and he doesn't like the machine, and he was one of the only complainants in the development process. So it was one of those things the guys were talking about this morning where it's kind of a perception issue, and he doesn't like the machine, but the noises he's complaining about are kind of not very real. And then the last one is we've had interference between an inverter and an operator of a ham radio, but the guy who installed the wind turbine was located at the same person as the house as he was operating the ham radio. So it was kind of one of those things where we said, this is your choice. You can operate the ham radio, or you can have a little EMI from your inverter in your house. I put up 6. When I was making this list, I had about 20, so I whittled it down to 6 things, wind power words to live by. Number 1, I think this is critical. Appropriately sited wind turbines can be good neighbors, are good neighbors. Number 2, wind power is a good thing. No one should be afraid to discuss a project with the neighbors and stakeholders from a very early stage. Number 3, be honest during the development process. I think more often than anything, problems occur because developers are not honest with the stakeholders and with the public. Don't be a guinea pig. Use tried and proven technology. Have a plan for long-term operation and maintenance, and everyone's viewpoint is important. Dismissive attitude by a developer to someone that has a concern about a project is oftentimes something that can cause a great deal of problem. What does it mean to be a good neighbor? Good development should start with appropriate residential setbacks. We shouldn't put wind turbines on top of houses, right? And so this is right out of SED's sort of developer's guidebook. This is the stuff we teach we have a team of 20 people now that work for SED, and this is what we teach them. If 100 kilowatt, if you cannot be 300 feet away from a residence, start over, find a new site, move the turbine. Simple things, going on up, 1.5 megawatts. Ours is 1,500 feet. This is not to say turbines can't be closer or don't need to be further away than these distances. It's simply to say this is a good practice to start with. If you're in a place like Worcester, Massachusetts, where the Holy Name turbine is, and you have an ambient sound, a minimum ambient sound of 58 dBA, you really don't have a problem being a little bit closer. Noise is not going to be an issue. Start looking at other things. So this is just sort of a guidebook that we start with. But everyone should have these sort of safe practices as they start development process. The second is to get out early and often. 2.5 years before we installed the Holy Name turbine, we were actually hosting public meetings at the school for all abutters and all stakeholders. And as I said before, we've had really next to no problems. Community wind, which is our primary focus, we rarely have to compete for transmission or for land rights. So there's no reason not to share the information about your project from an early stage. Also, by the way, community wind involves cooperation with all the stakeholders by its very definition. And again, there's no need to wait for the public hearing process. Host your own meeting, invite people, have a dinner, have a barbecue, whatever it is, but have a conversation and initiate that early. And then know your project and do your homework. Don't start talking about a wind turbine if you don't know what it is. And I think a lot of folks have gone down the development path with little or no knowledge about what their intentions were for the project, and that's caused them some heartache. Be the honest developer. The guys mentioned it earlier. We used to say wind turbines don't make any noise. That's a flat lie. They do make noise. They don't make an overwhelming amount of noise, but they do make noise. I can say that. I have one at my house and 2 at my office, so I can say that I live in and amongst them. But let's be honest, wind is cost competitive. It reduces emission from fossil plants and reduces the production needed from nuclear plants. It has environmental benefits that far outweigh the risks. Wind will be part of the energy future, and if properly maintained, is an inherently safe technology. These are facts. Wind, like all energy, is subsidized. Let's be honest about it. All energy is subsidized, so is wind. So what? Let's move forward. Wind does make noise. It does cast a shadow. It is an intermittent resource, and it does have an environmental impact. We may have to clear a tree, and it makes a little noise and all those sort of things. I think being honest about the things that wind is and the thing that wind isn't is key to being a good developer and properly educating the public. Don't be a guinea pig. Wind energy, 30 years, Ben's been in the industry. It's not a new technology. Turbines have been around a long time. They've been improved. There's no need to go buy the first machine hot off the presses. We have a lot of turbines out there. Make sure they have some history and they're finance worthy. Hire experienced contractors. We don't want to drop the things. We don't want to do anything silly like that. Hire people that know what they're doing. Follow best practices for environmental regulations when performing siting studies. It was mentioned earlier by the noise guy, every state in the New England has some level of noise regulation. The IEC tells us how to measure sound. So follow these practices. Don't come up with your own new way of telling someone what the sound that a machine will make is. Make sure your information is accurate. Do the best job you can. And then operation and maintenance. I think this is the number one most important thing. Like any inherently safe technology, appropriate maintenance is required for wind power. If you do not properly maintain a machine, it can become unsafe. We hear all the time in public meetings, what about the thing I saw on the internet about overspeed? Well, the machine was most likely not properly maintained. What about blade cracks and things like this? Some of our partners require us to put a little camera down the blade every time we make maintenance of the machine. These are things that can be done to protect and make the machine safe. So I think it's really critical, that appropriate. And I think it's also critical, one of the things we've done now on 4 or 5 of our installations, people will get fearful like that their local firemen don't know how to maintain the machine, they don't know how to work at heights. Train them. Pay for them to go get trained. It's not a big deal. It doesn't cost you a lot of money. A couple of projects we can go through. The main reason I put them up here was just because of the local challenges that we had. Jiminy Peak, there was no zoning when we put up that machine. But what did we do? We met with Eleanor Tillinghast about 18 months before we ever beat it. Now, Eleanor's been a vocal opponent to wind power in western Massachusetts. University of Delaware, we had all kinds of wetlands issues, and there were properties, now they're saying we were too close to homes and all those sort of things. So we had to have a very careful 2 years again before we started building that project. We were out talking to the neighbors. The Berkshire East project, there was no wind-related process, a very uneducated public, and we had to work with them for 18 months. It took us 8 months to permit that project. At Holy Name, we started 2 years before we built the turbine within exclusionary zoning rules, meaning they said, no, if it does not specifically say you can build a wind turbine, then you can't. So we had to actually get the bylaw changed before we could even apply for a permit for the machine. This is also in an urban location, and it is 800 feet from the nearest home. City of Medford, again in an urban site, we had polluted soils, we're in a municipal park, there's literally a playground right underneath the turbine. Again, some local challenges, but an example of how wind can be sited in and amongst where we live. And then Country Garden down on the Cape. This machine has been a very interesting case for us. We knew and were committed to the fact that it was a relatively aggressive siting. And it's under 200 feet from the nearest residence, but we were able to work with those residents and make sure people were comfortable with the technology. And we've had, like I said, just the one complaint on shadow since we've installed. Thank you for your time.
Thank you, Kevin. So now we're into the panel question and answer session. So I encourage you we're going to do cards if that's okay. We have probably 4 minutes or 5 minutes of questions already teed up. So while you're thinking about this and hopefully getting some thoughts rattling around, we'll start asking questions of the panelists. We're picking up 2 other folks. So we've got 3 folks who you do know, but we're picking up Ken Kaliski, who's an expert in acoustics and air emissions measurements. He's PE and board certified through the Institute of Noise Control Engineering, and is a frequent presenter at AWEA and other venues. We also have Matt Allen joining us, principal at Saratoga Associates, peer reviewer for NYSERDA's conservation program policy on visual assessment and mitigation. So another expert on mitigation and visual analysis. So to this end, I'm going to go ahead and tee up. We've got a number of questions, a couple for Ben. How can you accurately assess property value effects made if homes near the turbines are not selling? Does that make sense? So in other words, where do you get your data if things aren't selling?
Yeah, if a home doesn't sell, you can't estimate the effect. But if the home next door sells, you would assume that the effects are going to be similar. And so there's 2 things there. One, we do have data of homes that sold. So we assume that the effects that we are estimating are similar to ones that didn't sell. And secondly, part of the LBNL work from 2009 that I mentioned earlier today, we made the first crack at estimating the number of sales at various distances and over those various periods, meaning close to the turbines and further away and during announcement and post-construction. And figured out the percentage of homes that were available to sell that actually did sell in those various time, space periods, and found it to be pretty similar. There looked like there was a dip after the wind facilities became operational for those inside of a mile, but then that came back up to more normal levels. So again, we think there might be something there, but it's not taking away from homes that actually do sell, there is data, and we think that the estimates we derived would be similar for homes that didn't sell.
So this is a little embarrassing. I was in such a hurry to get to the panel section, I forgot to present. How about that? Talk about cutting yourself off a little bit. Ben was looking at me like, what is wrong with you? So this is setting the stage for this actual conversation. The notion here is that when you have a project, the developer, especially if it's somebody who wants to have value in the project, is trying to maintain a sense of value for the project. The colors on this graph are a little odd, but they're trying to keep it up into the red, trying to keep the project red line. And there are a series of forces that are kind of pushing this thing into the non-optimal space, and some that push it right into a well from which it can't recover. And so one of those is siting. You know, if you have enough opposition, Wisconsin almost had this recently, where a moratorium was about to happen, a couple-mile setback, which basically would shut down Wisconsin for any wind development at all. So that's an example. If we don't manage the conversation effectively, and we have in the conversation enough strong reactions that people say, you know, we're not doing it here. We're going to have a moratorium that's going to last forever. That's a problem, and we end up in a well and we don't do anything at all with regards to wind development. Yikes, I'm being under attack here. Other ones are wildlife. Those can be managed. But again, it's always walking the fine line between trying to make things work and trying to make people happy and trying to make sure that we minimize our acknowledged impacts on the environment around us and making a project that actually works. I think the lunchtime speaker was quite there in terms of, listen, if we don't do something, and Ian kind of referred to this as one of the ends of the spectrum, but we're going to cook the planet. And that is a real possibility. The other one is that as we try to compete with this natural gas band here, our projects, as we add mitigation costs, push our projects out of the competitive range. So if we want to be able to compete and continue to be the next largest generation sector, we have to manage our mitigation costs. This is a pie graph of sort of where mitigation, permitting and siting is where this section falls, is actually a fairly small development budget in the project development process. There's a lot of pieces of the development pie, and only 10% of it for most developers of larger projects is really expected to be spent on mitigation. So when we have elements that are maybe not less scientifically based, and we spend a lot of our budget on that, we have less money to spend on avian mitigation, et cetera. So just keep those kinds of things in mind as we go forward in this next one. We don't need to do the ground rules. This is today has gone way better than I think. Than I anticipated. So, next question, Ben. When do you recommend property value guarantees? Is there such a thing? The question is, so the notion would be, hey, developer, you tell me that it's not going to hurt my property values. Are you willing to guarantee that?
Right, I think this is a better question for Kevin.
There you go.
Because I'm a researcher, I'm not a policy guy, and I think it's one of the tools in the toolbox, but it's really up to them about whether it makes sense to do.
From a practical experience perspective, the answer is I don't understand how you possibly could guarantee someone's property value. I know I have a wind turbine at my house. The property value went up. I don't understand the question. I don't understand the point of the question. So I have a hard time answering. I unfortunately sound like not an expert at all in answering that question. So how do I guarantee someone's property value? I don't think it's something I could do. And it's something from a community wind perspective that would kill a project. So I could never use that from a practical perspective, I could never use that as a mitigation technique.
All right, good answer. So here's one. I'm going to give this to, let's see, this is a bird one. Can you put this in the mortality impacts from wind turbines in context with other anthropogenic means such as the windows, power lines, cars, etc.?
I have not done a specific assessment of different mortality issues, but I know that communication towers are a huge mortality issue for birds. And it's conceivable that one mitigation tool might be to retrofit a nearby communications tower with appropriate lighting, which could make up for the, that reduction could make up for any increased mortality that a wind facility might cause.
That's a fascinating proposal. I think the number that gets batted around the industry is 1 in 10,000. So it's a 10,000 to 1 ratio. For every bird that interacts with a wind turbine in a mortal fashion, there's 10,000 that are lost through windows, cars, house cats, etc. That's in the NWCC summary of whatever, avian interaction studies or something from 2003. Let's see, noise. Should noise be monitored or conducted at property lines or at houses?
So there are two major impacts of noise. One is on activity interference, such as speech interference, and the other is on sleep disturbance. So, I think that it's appropriate if you're looking at a sleep disturbance standard or standard that's based on sleep disturbance to measure that at the home or somewhere around it. And if you're looking to protect against activity interference, like speech interference during the daytime, then that might be some type of property line standard or area of frequent human use standard.
A similar one in terms of safety. When we think about setbacks for safety, which I imagine would be ice throw or something else catastrophic, who has a perspective on what's that setback? Is that a property line, or is that from occupied homes or other structures? Is that good for you, Ben?
I'm not sure from a permitting standpoint. I would say the setbacks, generally you're seeing them from property lines as opposed to the structures themselves. But those setbacks obviously depend on the region that you're working in, but generally on the order of probably 1,500 to 2,000 feet.
I'll throw in there as well that, they're just like we talk about bird and bat and noise and all those other mitigations, ice is now very mitigatable as well. For instance, we're in final permitting and about to start construction on a 900 kilowatt turbine that's located about, 175 feet from an industrial building, and we have added an ice monitoring system. So if there's ice on the machine, in the past, wind turbine shut itself down when the blades become imbalanced, which may or may not be before it collects some ice. Now we're in a position where we can actually shut the machine down if there's any ice on the machine whatsoever. So this is a mitigatable item, just like anything else. And so I think from a practical perspective, it becomes a relationship with the planning board and with the neighbors to figure out where it's appropriate in terms of the distance from neighbors' property lines or their residences.
This one's again about curtailment for wildlife. When we looked at curtailment for wildlife, we were thinking about hours of the day for bats and wind speed, of course, and we were looking on the southern lakeshore of Lake Erie, so we were worried about migratory birds coming and going. And one of the notions was during the migrating period, you'd shut it down unless the wind's coming from the wrong direction and the bird wouldn't take off over the lake in a strong headwind. Have you heard much about that in terms of curtailment for wildlife and whether that's effective for birds as well as bats? I mean, we saw the example with bats, but have you seen it for birds, migrating birds?
I've heard it discussed. I've heard it discussed. I've also heard options discussed where radar would be used to detect large migrations headed in the direction of a facility and use that as an early warning system as well. But these are all still kind of in the early experimental and development stages.
Thank you. Ben, your results imply a lack of effects, but we've seen some yet others have shown large negative effects. How can stakeholders determine which is the right answer? When do we know what's a good study versus not a good study? Is there a way to tell where the funding comes from? Or
the highest bar is peer-reviewed published. And I think that you can trust that at least that has gone through as much review as probably is likely. The next step that I sort of think about is of the quality that would be published, and so it's using very similar techniques as what is in published literature, and that sort of captures a lot of the academic literature that I showed today. Also, if it's produced by an academic institution, they usually have less motive for other purposes. I do think funding is an important qualifier, meaning who's paying for the study, but really you have to look at the work itself. If you're referring to, there's some work that estimated some very large negative effects, that just work that would never be published. It's a very simple analysis, and that is the conclusion that they drew. But compared to the level of the work that not only I reviewed today, but is in the literature in general, looking at disamenity effects on property values, it doesn't compare. And I think that's the important distinction.
Ken, there's some questions about Vinyl Haven and some statements about, or comparisons about noise, about how it might sound like something else, perhaps an air conditioning unit or something else. But there's now some feedback that we heard earlier that it doesn't match up with people's notions of what an air conditioning unit would be. How do you explain those kinds of differentials when you're communicating with people about these projects?
The best way to figure out what a wind turbine sounds like is to actually see one and stand however many feet away that you would be impacted. So if you were if a wind farm is proposed near you that is going to be a couple of thousand feet away, go to a similar type of wind farm, preferably at night, and observe those levels. If you can't do that, if you want to know the character of the sound, there is a simple way to do that, and which kind of mimics the swishing sound of a wind turbine, and the mechanics of it is just to put your finger up to your mouth and blow as you move it away back and forth. That gives you the character of the sound, but it doesn't. I think going to a wind farm and seeing for yourself is the best way to actually understand what it sounds like.
Thank you. Matt, we didn't hear very much about shadow flicker. I think we ran out of time earlier. Can you give us just a couple-minute introduction as to what it is, what its reach is, when it's most annoying? I think there were a couple inferences to it. And then curtailment strategies and how effective you've seen those to be. Do you mind?
Sure. Very briefly, shadow flicker is, as you would expect, when the turbine falls in a direct line between the observer and the sun. Shadow flicker doesn't happen all the time when the sun's shining. The flicker actually only happens when you're in the physical shadow of the turning rotor, and it creates a pulsating pattern. It's typically most evident when you're inside a house. I think you all know the circumstance when you're sitting in your living room reading and the sun is low in the sky and it comes directly in the window. If you can picture somebody standing outside the window waving something that blocks the sun in a pulsating pattern, that would be similar to shadow flicker, and it can be an annoyance. There's some question as to whether there might be health effects associated with that. I'm not going to get into that because I'm not an expert, but what I've read is that it is an annoyance, and it has not been known to trigger epileptic seizures or anything like that. But it's a legitimate impact, and it's an annoyance. The good thing about shadow flicker is that it is precisely calculable. There's software out there that will tell you exactly what time of day and what day of the year a shadow will fall at a particular home. So that makes it easy to mitigate. If you know exactly when it's going to happen, and typically it would only happen either early in the day or late in the day when the sun is low in the sky and the turbine's casting a long shadow. And obviously it's only going to happen morning or night from one turbine, depending on whether you're to the east or the west of the turbine. But if you know all that information, the easiest thing that a developer can do is program the turbine to shut down at that particular time. Turbine developers would prefer not to do that, but if it becomes a significant issue, the turbine can be programmed to shut down during those times a day or days of year that a particular person might be affected. The extent of shadow flicker might be up to typically 8 to 10 rotor diameters is a measurement. So you might be outwards of a half a mile before the shadow would begin to dilute enough that you wouldn't notice it as an impact. So if you're beyond that half a mile zone, typically it shouldn't be a problem. But again, mitigation can take the form of shutting it down. Obviously, you can close your shades. That's a pretty effective way of doing it also. And happy to go further if anybody needs it, but I'll let some other questions go.
Thank you very much. Gene, you described a few mitigation notions where you're removing machines from the foreground. Can you describe did they share with you the effect on the project economics, and can you think of other visual mitigating strategies, such as I've seen some intercons, for example, in Europe, where the base of the tower is in grading green, so they don't stand out against the lower landscape, but you see white above to blend in with the sky. Are you familiar with other things like that?
Yeah, I mean, vaguely, yes. But yeah, regarding the slide example that I gave, I hope people can hear me. That was something the developer asked me early on. So clearly they really wanted to know the answer to that. And of course, that probably made the difference between them getting the permit and not getting the permit. So there were the economics worked out. And this is I see it frequently used. I mean, a lot of projects ended up being reduced in scale meaning number of turbines for one reason or another. Sometimes it's a wildlife issue. Often it's a wildlife issue. The one in the Deerfield project in southern Vermont was reduced, but it was not for aesthetic reasons. It was because of beach-scarred bear habitat. So there are, I think that's part of the discussions that happen as these projects get a little further along in the process, and there probably is a sort of breaking point where the reduction, too many turbines being taken off for consideration may break the project, but that's something I wouldn't know about. Let's see, you asked about color. Okay, that's an interesting discussion to me. In Europe and certainly in perhaps more in New York State, a lot of the turbines that are being proposed are sort of more in agricultural settings where probably half the turbine is seen up against the sky. Most of the ones, at least in northern New England that I'm familiar with, tend to be more on top ridge lines or hilltops, and so they're usually seen against the sky. My own personal opinion is that I think that the white color aesthetically has some real benefits, contrary to what a lot of people think. But for one thing, a sort of half and half to me would be far more visually intrusive than just keeping them very simple. One of the reasons that I think people find wind projects to be visually attractive, one of the reasons, is the repetition of like objects in the landscape. It's one of the basic principles I use in garden design, to be quite honest. They become something that has a rhythm throughout the landscape. There's no one object like a cell tower that draws your eye, that becomes a focal point. So I think there's a simplicity to it. The white color, in my mind, is a far more cheerful color than industrial gray. A lot of people say, why don't we make them industrial gray like cell towers? I think that's one of the reasons that people find cell towers so ugly. White is a color that is associated with Greek temples. They're sort of like temples to the wind. Another factor is the movement. We can, unlike cell towers where you have no idea how that electricity is being produced unless you're an electrical engineer. We can see it. We can make a direct visual connection between the turning of the blade and the wind and the logic of why what that object is doing and why it's in that location. In fact, one of the studies has shown that the most visually obtrusive things in terms of wind energy projects is a turbine that is not working. And one of the mitigation strategies I sometimes recommend is if a turbine breaks down, repair it immediately, because people do not like to see them sitting there without turning.
Thank you very much. There's one question here about, and I think, I'm not sure who to give this to, but it's, so would the appropriate person please step forward. If a house is located on a large parcel, farthest away from wind turbine, should the development potential of the wind land closer to that property line be sacrificed? In other words, how is it appropriate that we sacrifice the back 40 when there's nobody there to be annoyed? Is there anybody who can address that effectively? That's a kind of a landmine, if you don't mind.
I don't think it's a landmine at all. There's no one-size-fits-all solution to a question like that. The way to handle that question is go to the neighbor and talk to him. How do you feel about me siting a wind turbine near your vacant part of your property or near your populated part of your property? You can't answer these questions without just having a good conversation with them and explaining what the potential impacts on them might be and their property might be.
That's a good answer, and that's what you'd call a participating landowner. You might get an affidavit from them or something else, but then the question is, how does that live on past that landowner?
Participating or non-participating, it doesn't matter. You have it's about a dialogue. There's no reason to say, I'm not going to try and put a wind turbine here. I am going to try and put a wind turbine here. It's going to be overshadowing your property. Would you like to talk about how that might impact you and just create a nice dialogue?
Good. Benjamin Bell. Can you describe a few technical approaches that people have gone through, maybe even in the past 10 years, to reduce turbine sound levels?
Yes. As far as blade design is concerned, there's a couple aspects of the blade that you want to consider when designing it. The tips of the blades, by the shape of those, and can help reduce the sound, as well as in the trailing edges of the blades. Often you might go out into a wind project and hear a whistling blade. Typically that's very characteristic of a blunt trailing edge. So you find if you make the trailing edges very sharp, bring them to a fairly narrow point, you'll eliminate that whistling noise. So obviously rotor design is pretty important. Speed is also pretty important. The faster that you turn the rotor, the more noise you will get from it. So that generally, even though you get efficiency increases by running the rotors faster, typically people will design them for low rotational speeds, low design tip speed ratios to keep the noise down.
We had some projects where we had turbines who had oil cooling systems that ran 24/7. And we worked with the manufacturers to dial those back to being a 10% or 15% duty cycle when the turbines weren't operational. Have you seen that in other machines? Are people coming up with different control systems for that?
Well, I've seen a lot of the sort of vibration isolation, and also inside the nacelles, often you'll see the turbine manufacturers putting 1 to 2 inches of acoustic foam to be able to contain the noises inside the nacelle, and also mounting machinery on sort of isolating the vibration in the various structures so you don't get a resonance. Mm-hmm. Keep the rotating machinery away from large plates or the tower structures that actually could resonate and increase the noise.
Yeah, we saw some turbines also where people didn't grout the bottom of the tower. They act like a great big megaphone right to the bottom. It's kind of problematic. There was a brief mention earlier today about active noise cancellation. Is anybody familiar with that? Has anybody actually done that besides just handing out Bose headsets to people who live nearby? Is there actually something out there that's true? Oh, look, there's a stop sign. Really got to stop. How time is it? Oh my gosh, time for lunch. Anybody have any things on the? Okay. There's a couple questions left, and I encourage you, if you haven't had your question answered, please come up to the panelists. We do have a little bit of a break. Before we move there, can we ask for a sentence from each one of you, just going down the line of your parting public thoughts before the end of the session? Starting with you, sir.
Do we have to? Okay. So I think noise issues are going to be, as they are now, an important part of the permitting process, and it's just something that we can get through much easier when there's some of these folks have said, a dialogue, an honest dialogue between developers and the people that are affected by the project.
Quickly on shadow flicker, I think right now there's a lack of data out there, and I think as wind turbines become more prominent in this part of the country, people will experience that impact more, and we'll have better data, and mitigation will be more direct and upfront and taken into account early in the project without people ever having to be disrupted by it.
So with regard to aesthetics, similar problem in that we have so few projects that we can look at this point and see what the aesthetics impacts are through direct experience. So I'm looking forward to being able to see some of them up and running, and I'm hoping there's going to be some data, some studies, more studies that are done on these, because we have, there's plenty of anecdotal evidence, but it'd be nice to really get a sense of how people react to these projects as they move forward. I think you might have to take.
From a mortality perspective, clearly more research needs to be done, but I personally believe that the answer to mitigation there is going to be operational. It's specific times of year. In some cases, with birds in particular, it's specific weather conditions, and I think once we learn more, it will be possible to predict the problem nights and address those issues with curtailment. In terms of habitat issues, we just really don't know enough yet, and we have a long way to go there.
As regards property value impacts, I applaud more work. I think that there's still some important gaps here that leaving a lot of people, even hearing what I said today, scratching their heads. So hopefully in the next year or two, we'll make the same amount of progress we made in the last year or two.
And I think with respect to the wind turbines and the design architectures that are currently coming out, you see machines are moving away from using gearboxes, which also are a source of noise, moving toward direct drive units. The turbine manufacturers are constantly working to update their products to make them quieter, and machines that are 100 meters in diameter plus are quieter than smaller machines from years ago. So as the technology evolves, I think the manufacturers have this as a primary focus, because you got to consider things like noise or wasted energy. And so if you can capture that energy and turn it into electricity, that's better for all.
I will leave you with two parting shots from the non-technical mitigation category over here. Parting shot number one is actually in contrast to what Ben said, and not necessarily in contrast. The turbine size for the large wind farm community is absolutely growing. Offshore turbines are getting bigger. However, there's been an underbelly of growth in the mid-sized turbine category, which I would call something like 500 kilowatts to a megawatt. And we're actually putting in place projects now that are cost competitive with megawatt class machines right now. And so the simple statement is bigger is not always better. That's one mitigation technique. Then the second, and this is one I actually meant to mention when I was presenting, I think the single biggest problem in particularly in Massachusetts wind development is lawyering up. We have never been turned down for a permit for a wind turbine in the Northeast, and we have never hired a lawyer to help us have a discussion with a project stakeholder. And I think that it creates a natural controversial atmosphere rather than a dialogue between two or a group of human beings. So I really think that getting the lawyers out of the room and getting the stakeholders in the room and having a dialogue is the best path forward.
I like that note on which to end. I feel sorry for any lawyers that we may have offended, but But I think that's the right idea, and I really appreciate the tenor of the conversation today. It's been a fantastic day, I think, and can we thank our panelists and speakers as well? And feel free to approach them. They won't run away for a little while. I'll guard this end. Yeah.
Hey, Bob.
Bob?
Do you want to introduce the next group now? I mean, what's going to happen next, so everybody knows?
I think we have 10 minutes left.
Yeah, so we have a 15-minute break now, and we're going to be now moving on to the workshop phase of the day. So take a look on, sorry? At 3:05, we'll be starting those. So the different rooms, there should be labels on the outside of the rooms. Here we'll have an opportunity to talk to each other about a series of issues that we've laid out. And we've used your survey, your pre-conference survey input to help prioritize some of those issues. Then we'll come back together again in a plenary session and talk about what we've learned. Thank you.